This is Numbers with Nicole, and our lesson today is on arc measure and central angles. So our goal is that you can find the arc measure of an intercepted arc, or the central angle measure for that matter, if we're given a central angle. So if we're given one piece, can we find the other? If we're given arc measure, can we find the central angle? And if we're given the central angle, can we find the arc measure? So what is an arc? An arc is a piece of the circle's curve. So how many degrees do we have of this curve is what the arc measure is. So how many degrees are in the arc? The symbol for arc is an arc. So just like we draw an angle to represent an angle, we draw an arc over the arc that we're naming. So what does that mean? So an arc of a circle having a measure less than 180 would be called a minor arc. So AB, this arc right here, AB, would have a measure that is less than 180, and we would name it by two letters. So we're going to draw the arc to represent that's what we're talking about, and then we're going to name it with the 2 points that represent the portion of the arc that we're discussing. So here's the 2 points, A and B. Here's the piece that we're discussing. So the arc measure is equal to the measure of the central angle, and we discussed central angles in the previous video. Those are angles whose vertex lie on the center and whose rays are radii of the circle. So we have our minor arc, which measures less than 180 degrees. So our central angle would be less than 180 degrees. And then we have the major arc, which would be more than 180 degrees, and typically we name this with 3 letters. So we could call that arc. So I'm drawing the arc, the symbol, ACB. So that's how I would represent the portion of the circle's curve that is bigger than 180. The total arc measure of a circle is 360, so the total number of degrees in a circle of that curve. Diameters create semicircles, which are half of a normal circle. So that means that arc measure would measure half of a normal circle, which would be 180 degrees. An intercepted arc is formed by the angles intersecting the circle. So notice I underlined angles and didn't just say central angles. There are other types of angles in a circle called inscribed angles that we could look at and look at how many degrees those form. But we're only going to focus on central angles here. So circle B shown below. Is angle ABC a central angle? Why or why not? Yes, angle ABC is a central angle because its vertex is at the center of the circle. Because angle ABC has a vertex at the center of the circle. Perfect. All right, now we want to name the minor arc. So we're going to name the arc that is less than 180 degrees. So how many degrees would be in arc AC? We want to know the measure of minor arc AC. And the arc measure is equal to the central angle. And our central angle here is 79 degrees. So the measure of the arc AC is 79 degrees. So how do we find the major arc? Well, if all the arcs in a circle is 360, we're going to subtract the minor arc 79 from that 360, and we get 281. And the major arc, which makes up the rest of this circle, which we said is 281 degrees, the major arc, ADC, would make up the rest of the circle. And if we put the major arc and the minor arc together, then that would be 200. Then that would sum to 360, and that's how we got 281 degrees for the major arc. If we extend CB to form a diameter CBE, so CB, so now we're forming a straight line. That's what we're telling you by saying that this is a diameter. So if we extend that, can we find this angle here? Let's just call it X. And in turn, can we find the measure of the intercepted arc AE? So we know the measure of arc AE will equal the measure of angle ABE because it's a central angle. And so we want to figure out how much that is. Well, remember, diameters create a semicircle or half a circle, and half of 360 degrees is 180 degrees. We already have 79 degrees of that. So when we subtract that, we get 101 degrees for angle ABE and for the measure of arc AE.